Hi everybody, here are the solutions to practice set number 5, which is on 5.4, which we're trying to apply the integral to different situations. So the idea, the main idea here is using those formulas from the notes, which basically say that if you integrate a rate, you get a net change. And that's the main one we're going to use. And then we also have the average value, which I'll get to in a second. So here, velocity is a rate of change of position. And so in this case, we're trying to figure out what's the displacement from 1 to 4. So all we need to do to figure that out is to integrate from 1 to 4 the velocity function with respect to time. And if you do this, you're going to get e to the 2t. We're finding the antiderivative of e to the 2t, which is this. How do I know this is antiderivative? Well, if you take the derivative of this, right? Let's just do this real quick. Let's take the derivative of this. I would get e to the 2t times 2, right? That's that u prime thing. And then it's all over 2. And so these 2's would cancel, and we would have that same thing that we have there, right? So that's how I know I have the correct antiderivative. And then we'd have to evaluate this from 1 to 4. What this means is that we plug in 4, and then we subtract what we get when we plug in 1. And in this case, the simplest it can be written the simplest you can write it as is something like that, right? And you could get a calculator to calculate what the decimal representation is, but you don't need to. Okay, next one. The rate at which gravel processed at a plant is modeled by this equation. It's that same equation we did on the notes. In tons per hour, find the total amount of gravel processed from t equals 3 to t equals 6 hours. So if we want total amount of gravel processed, then we need to know the integral from 3 to 6 of, in this case, because we want the total amount, we want this absolute value. Because there is some negative values in this one, right? So it's at some point there was like some sort of negative rate. Not really sure what that means in this context, but there was a negative rate, and so we need to take the absolute value to disregard that negative rate. So to do this, this was a calculator one. This is one of the ones I said you could use a calculator on. To do this, we are going to, sorry, I need to change my calculator mode real quick. It's on a BC thing. We're going to, we don't really need to put in, it's not that complicated. So we're going to do math 9, which gives us the integral. We're going to go from 3 to 6. Somehow in here I need to put the absolute value. So what that is math, NUM, and then number 1 is ABS. And we're doing x squared minus 4. The x, it doesn't matter that the x and the t aren't the same. It's going to be the same answer. And we're going to get 51 tons, right? Since we're integrating it, that rate is no longer a rate, it's an amount, 51 tons. If there were 10 tons of gravel, I think I'd change this one a little bit. If there were 10 tons of gravel at t equal 1, how much is there at t equals 6, right? So we want a new amount. So this is that other formula where I need the amount at t equals 1, which is this, plus the change from 1 to 6. And this one, we don't want the absolute value because we just want to know where we are afterwards, right? If we lose some and then gain some, then that's, wherever we end up is fine. And so we're going to put this into our calculator. Again, we'll go through those steps. Math 9, we're going from, actually, let me do this. Let me set it up this way. 10 plus the integral from 1 to 6 of t squared minus 4 dt. In that case, it's x. And we're going to get 61.667 tons. right? This was the amount we had at 1. This tells me how much it changed by from 1 to 6, and that gives me the new amount after, from after that. Okay, let's keep going. Temperature outside in particular day, starting at 12 a.m. Since we're starting at 12 a.m., that's t equals 0. And we're going to noon, which is t equals 12. We want to find the average temperature, so this is an average value problem. So we're going to do 1 over b minus a integral a to b of whatever function that we have, right? So in this case, it's going to be 1 over 12 minus 0, right? This is a and this is b. Integral from 0 to 12 of 4t plus 70. This is not a calculator problem, so we need to do this by hand. 1/12 integrate, or find the antiderivative of 4t plus 70. You're going to get, after a little bit of simplification, 2t plus 70t. And we're doing this from 0 to 12. And so this is going to become 1/12 times, when you plug in 12, you're going to get, I guess I should just write this so you can see, 12 squared plus 70 times 12, and then it's going to be subtract 0, because when you plug in 0, you get 0. And if we do that, 12 squared is 144, times 2 is 288. 288 plus 70 times 12 is that, and then we have to times it by 1/12, which is the same as dividing by 12, but I'll just do it like this. And we're going to get 94. So the average temperature is 94 degrees. They didn't really say what. Hopefully that's Fahrenheit, because if it's Celsius, then we're all boiling to death. Number 4, velocity of particle moving along the x-axis can be modeled by this equation. They give us s of 1 is 5. Find the position of particle at t equals 5. This is that one where the new position equals s of, let's call it a, plus the integral from a to b of the velocity, right? It's the where you were plus where you went, right? This is, the integral is the displacement, the s of a is the position at the known time, right? So to do this, we're going to say, let me erase that real quick. We're started at 5, so we're going to put this 5 first, plus, what was the t value that gave us that 5? Well, it was 1. And then we want to go all the way to 5 seconds, so we're going to go to 5 seconds of 3t squared plus 4 dt. And we work this out. And it's basically going to be, this 5 is going to keep being there, so it's going to be 5 plus, we need to integrate this. The integral of that is t to the third. After some simplification, 3t to the third over 3 is t to the third plus 4t. And this guy is being evaluated from 1 to 5. So it's going to be 5 plus 5 to the third plus 4 times 5 minus 1 to the third plus 4 times 1. And then we do all this, and we get 5 plus 125 plus 20. 1 to the third is 1, plus 4 is 5, so it's going to be minus 5. And so that's going to be 125 plus 20 is 145, minus 5 is 140, plus this 5 is 145 is the new position. Whatever, 145 miles south of something, without a context, we can't say much more. Find the area of the region bounded by these graphs. We're on number 5. Basically, this is that same thing you've been doing. It looks a little more complicated, but it's not that much more complicated. We're going from x is 0, that's here, to x is 2, that's here, and we're bounded by the curve y equals x, and this function here, which is some sort of parabola, right? Like, doesn't matter. You don't need to sketch a gray graph of it, but basically we're trying to find this area. You have to remember that area is the integral, right? From 0 to 2 of this guy. Right? The integral will tell us the area under the curve, and it also has all those other applications as well. So we do this, and we get x cubed plus x, and we have to evaluate from 0 to 2. So this is going to be 2 cubed plus 2 minus 0 cubed plus 0. Again, I don't really need to do that, but do it anyway. 2 cubed is 8 plus 2 is 10. So we're getting, the answer is 10. All right, next one. Find the area of the region bounded by the graph. So another one here. It's helpful if you can draw a sketch if you need to, but I guess let's do it. If we're going from 0 to 8, right? 0, 8, y equals 0 is the x-axis again, and then this function, maybe looks something like this, and we're trying to find this area here, right? So we're setting up the integral from 0 to 8. We're trying to find the area from 0 to 8 of 1 plus, I'm going to go ahead and write this like this just to save myself some time, right? The cube root of x is the same as x to the 1/3. We integrate, we anti-differentiate, which is the 1 goes to x. X to the 1/3 goes to x to the 4/3 divided by 4/3, which ends up being multiplying by 3/4. And we have to evaluate this from 0 to 8. So we start by plugging in 8, and we get 8 plus 3/4, 8 to the 4/3 power, minus 0, right? That 0 so far has been really nice because it's simplified a lot of things for us. We need to do 8 to the 4/3. That's basically, here, let's do that on the side for those who are not familiar with fractional notation here. So 8 to the 4/3 is going to be the third root of 8 raised to the 4th power. So third root of 8 is 2. 2 raised to the 4th power is 2 times 2 times 2 times 2, 16. So this is 16 times 3/4, right? Which, this canceled that a little bit, which is 12. And then we have this 8 plus 12, which is going to give us 20. All right. Next one, find the average value. Remember, average value 1 over b minus a integral a to b of f of x dx from 0 to 4. So this is our a and this is our b. So we are going to integrate from 0 to pi over 4 to secant squared x. And I already forgot something, right? I need 1 over pi over 4 minus 0, right? That's the averaging part of it. So this is going to give us 1 over pi over 4, which could just be written as 4 over pi. The integral of secant squared x, we're thinking, what do I have to take the derivative of to get secant squared x? Well, you'd have to take the derivative of tangent, 2 tangent, right? Because there's a 2 there. And we're evaluating from 0 to pi over 4. All these things are being multiplied. So let's do this. Let's pull out this 8 pi, and then we're going to multiply by, plug in pi over 4, right? Tangent pi over 4 minus tangent 0. Tangent of pi over 4, unit circle, pi over 4 is right here. Tangent is sine over cosine. Both sine and cosine are root 2 over 2 here. So this is going to be 1 minus tangent of 0 is sine over cosine, so 0 over 1, which is 0. So this whole thing is going to simplify to 8 over pi. And yes, you should leave your answer like that. Yep. All right, next one. The volume in liters of air in the lungs. This is a cool problem because it kind of has some applications. The volume during a 5-second respiratory cycle is approximated by this model here. Approximate the average volume of air in the lungs during one cycle. So we want to know, like, on average, how much air is in our lungs during a cycle, right? And this was a calculator problem. So again, we just need to set up an integral. It says during the first 5 seconds, so we're going to go from t equals 0 to t equals 5, which means that's 1 over b minus a. We go from 0 to 5, and we're going to integrate v, which is this guy, and this is a calculator problem, so we're not going to worry about writing that whole thing down. We're just going to go ahead and put in v here, 0.1729 plus 0.1522 x squared minus 0.374 x to the third. And that's good, so let's go back here and let's say math 9. We're integrating, let's do the average value part first. So 1 divided by 5. 1 divided by 5. Okay, go away. And now we're going to do math 9 from 0 to 5 of that thing that we put in our y1 function there. And we're going to get a negative number. Does that make sense to have a negative number? We have negative 9 liters of air in our lungs. That does not make any sense. So let's see, what did I do wrong? There's supposed to be a 0, an extra 0 right here. Always check to make sure what you're doing makes sense. There we go. So on average, we're getting 0.5318 or 0.532 liters in our lungs. Next one says approximate the average rate of change during one cycle. Remember, rate of change is f of b minus f of a over b minus a. This is average rate of change. So that would be given to us by y1 of 5 minus y1 of 0 divided by 5 minus 0. So this divided by 5, and we get that. So it's 0.0011 negative. And this would be liters per second. All right, let's keep going. Find the displacement over the time interval 1 to 6 of a helicopter. Again, displacement is simply integrate from over the interval 1 to 6 of our velocity, which is 0.02 t squared plus t, right, dt. All I got to do is integrate that thing. So let's do it. Math, and this was a calculator problem, right? We said that. So from 1 to 6, 0.02 x squared plus x dx is 18.933. This was feet per second, so this is feet. All right, next one. Particle moves along a straight line. Velocity function is given by that, meters per second. Find the total displacement, right? We want displacement, so we're going from we use this same interval, so we're going to go from 0 to 4 pi of cosine t. Integrate cosine t, you're going to get sine t. We have to go from 0 to 4 pi, which this is going to give us sine 4 pi minus sine of 0, which turns out to be 0 minus 0, which is 0. Basically, we're saying is there is no displacement, right? Does that make sense? It doesn't make, I mean, yes, that makes sense as far as displacement goes, right? It's basically saying you end up right back where you started. All right, so 0 meters is our answer there. We want to know the total distance. Let me just show you something real quick. Let's go ahead and graph this just so you can see what this looks like. It's cosine x, right? And just so you can see, let's go from 0 to 4 pi. We know cosine only goes up to like 1, so that'll work. Right, so basically this curve is saying, yeah, we were going in the positive direction, and then, you know, Down here we went in the negative direction, and then we said positive again, negative, positive. But overall, we ended up right where we started, right? If you notice at the end of the graph, it's the same, or if you calculate all the positive and negative areas there, they would all cancel each other out, is what I should say. And so you basically started where you stopped, or you stopped where you started, which is why question B is interesting. Let me do something real quick so I can actually draw on this. Bring this over here. Okay, come on. Go up here. All right, anyway, what I want to show you is that, maybe I put it over here somewhere. All right, that if I took all my positive areas, which I'm doing in yellow here, and added them with all my negative areas here, I would get 0, right? But what we actually have to do for the next one is we have to add we have to make all the negative areas positive, right? So I need to make basically these negative ones positive up here and then add them all together, right? And so to do that, you have to take the absolute value of each one. It's a little bit harder to do by hand, but you basically need to know, well, when does this cosine graph start being 0, or start going below the x-axis, right? So we'd have to integrate from 0. When does cosine start being negative? Well, it starts being negative at pi over 2. So we integrate from 0 to pi over 2. And then we add that, and we take the absolute value of that, plus the integral from pi over 2 to when does it start becoming positive again? That's here, which is at 3 pi over 2. And we take the absolute value of that. And then it's positive until 5 pi over 2 again, right? Which is, just write these on here, right? This is 3. This is pi over 2 is when it starts being negative. This is 3 pi over 2 when it starts being positive again. This is 5 pi over 2. And then the last one we're going to need is right there, which is basically 4 pi's at the end, right? So it's 4 pi minus pi over 2, which is 7 pi over 2. So the last one would have to be 5 pi over 2 to 7 pi over 2. Right, and then you have to take the absolute value of each one individually. The nice thing about this is they're kind of symmetric, so it's probably a lot easier than you might think. And the antiderivatives are all the same, right? So this one just sine t from 0 to pi over 2. This one is sine t plus pi over 2 to 3 pi over 2. And this one is sine t, and we have to take the absolute value, right? Sine t of from 3 pi over 2 to 5 pi over 2, and this one is sine t from 5 pi over 2 to 7 pi over 2. And so this one would be sine of pi over 2 minus sine of 0, which sine of pi over 2 is 1, so that's 1, and absolute value of 1 is 1, plus sine of 3 pi over 2 is negative 1, right? That's down there. Negative 1 plus 1. And then this one's going to be sine of 3 pi over 2 is, 5 pi over 2 is 1 minus negative 1. And then this one's going to be, again, 1 minus 1. which just ends up giving us 1 plus 1 plus 1 plus, this ends up being 2. 1 plus 1 is 2 plus 1. And then this is absolute value as well, plus, so 1 plus 1. So this is 1, 2, 3, 4, 5, 6, 7, 8. So the answer there is 8. Because all those negatives have to become positive, right? So that's how that goes. I'll make a different video for the FRQs.